It's not the GPU cost that bankrupts a roadmap, it's the constant cognitive load and integration debt. We call the strategic drag the AI ops black hole.
Your engineers spend most of their time on wiring this infrastructure together and putting all the tools together instead of improving the models and the user experience. And that is what derails the AI roadmap. We're paying these engineers an ungodly amount of money, as they should be paid, But to take your best engineers and have them spend time on manually correlating things across the pipeline, that is just insane. And we would have never known it if we didn't have the complete trace of every call that the model was making.
Can I say that you had accidentally hired a super productive, slightly reckless junior engineer? And the complexity you describe, it basically erodes the business confidence in the model. They think there's something wrong with the model. We all joke is like being on is not the same as being functional. Hello, everyone. Welcome back to AI Cloud Essentials, a new podcast series brought to you by CoreWeave. I'm your host, Ritu Jyoti, an independent AI value strategist, CEO of a stealth AI startup, and most recently as the GVP GM of AI automation, data and analytics, market research and advisory practice at IDC. So today I'm super excited because we are on episode 3, diving into what I believe is the single biggest hidden tax on AI ROI, complexity. It's not the GPU cost that bankrupts a roadmap. Is the constant cognitive load and integration debt. We call the strategic drag the AI ops black hole. This isn't just an IT issue. It is a massive, invisible drain on the developer time and business agility. The problem as we see it is the complexity trap created by running AI workloads on general purpose clouds. So today we are going to dissect this problem and show you the way out. I'm thrilled to be joined by a true expert on the AI lifecycle, Lavanya Shukla, Senior Director of AI CoreWeave. Welcome, Lavanya.
Thanks for having me, Ritu. And I'm really excited to talk about this complexity trap because this is exactly what we see with our customers. So we see that these teams can train really good models, but they really struggle to put it into production because when they're testing out the models in a POC, you can glue together a bunch of tools, you can brute force all of the orchestration, all of the monitoring. But the moment you start putting these models in production and the moment you get to scale, you have dozens of models, you have multiple clouds that you're deploying different pieces of the puzzle in. You have a bunch of self-hosted workloads and a mix of different APIs. And there's really no consistent way to see what's going on. But that's one set of problems. There's another set of problems where AI, as we know, is very probabilistic. So you could run the same piece of code and it would totally behave differently. And you could run the same piece of code today versus tomorrow. It doesn't mean you'll get the same result. And that has to do with how GPUs work internally. But this uncertainty combined with this fragmented stack across different clouds means that your engineers spend most of their time on wiring this infrastructure together and putting all the tools together instead of improving the models and the user experience. And that is what derails the AI roadmap.
Yeah, Lavanya, I mean, that was music to my ears, how well you articulated it, right? And if I may say, these cumulative, can I say that they're undocumented? Because a lot of times when I engage with the end users, they're not even aware of, they can't think through. Of course, the developers are aware of. These undocumented efficiencies are really the single greatest threat to AI roadmaps. Today, we aren't just discussing a faster cloud, we are outlining the architectural escape velocity required to turn the AI prototypes, because it's not about prototypes. We have to run reliable, profit-driving systems. So this is just a fantastic, start to this whole discussion. And I'm going to talk about now the problem, the black hole special drain on AI. So let's start with the operational nightmare. In my work with the CIOs, I've noticed a shared anxiety. Traditional AIOps, as you said, built for deterministic web services, are completely insufficient for probabilistic AI. Many people don't understand this nuance. And this problem is escalating fast. We're not just running classic machine learning models anymore, especially the advent of Gen AI and autonomous agents. They introduce entirely new threat surfaces. And in these systems, model drift, prompt injection, and hallucinations, they're not just errors, they're fundamentally tied to customer experience and legal compliance. So, if I may ask you, Lavanya, where are you seeing these fundamental disconnect manifest most painfully in your conversations and your interactions?
So the biggest disconnect that we see is that, as we talked about, these AI workloads are very probabilistic and they're very dependent on data. But most of the tooling was built for a software world, not a machine learning world. Machine learning world is more like a research scientist where you're running experiments. With software, we know we write this code, it's going to work the same way. So these tools, because they're built for deterministic services, if you think about how you measure these tools, uh, you ask, is the service up or are the error rates spiking? And like that's not how you could measure like these AIOps tools. For AI, the real question is this model still accurate now that the internal makeup of the customer data has shifted? So suppose we see this example in like if you have spam detection, you deploy it, the spammers start like, working around that model that you just deployed. And like we see companies deploying a new model every hour because like the makeup of the data has shifted. So being able to tie this model metric to the business metric is really hard. And also on the general purpose clouds, you see this fragmentation task where your training logs are in one place, your inference metrics are in another, your GPU utilization, data quality checks, your incidents, they're all living in all these separate places, and none of them are aware of your model or of your business metrics that you're trying to optimize. So we see teams spend so much time just gluing all of these things together by hand to be like, to answer a simple question like, did this GPU incident cause this drop in the output of the model? So the black hole here is connecting the infra tools to this model centric reality.
This is so something that we all can resonate with. There are silos of information and there's not interconnection there. So this is exactly, I found that the fragmentation tax is actually compounded by a trust deficit. And the complexity you describe, it basically erodes the business confidence in the model. They think there's something wrong with the model. But we all joke is like being on is not the same as being functional. And that is the most critical mind shift for enterprise AI leaders right now. So, Lavanya, would love to hear your take on this.
Totally. I totally agree with you. Like being on is not the same as functional working. And like a model can be perfectly healthy from the infra standpoint. All the checks might be passing, but it could be completely wrong for the business. And this is where we see a lot of like data scientists or like machine learning engineers, my people, like will be like, oh, this model that I built is like low latency and like it has the best accuracy, but it cannot be tied to the business metric. And you don't have one place to look at all of the different things. Like, a manager can't come and correlate the model accuracy to how it's going to perform in like a production database, a production use case. So that's why we built things like weights and biases monitors and like the weave tracing, and because they're model aware, they're built by machine learning engineers as they used to be called before they were called AI engineers and for machine learning engineers. So you can do things like watch the accuracy of on cohort X of your user input data versus cohort Y, and you can see is that drifting or not. And you can trace these end-to-end executions from like data sets to like the models to in production data. Another example I might give is self-driving cars are regulated. If the car sees like a weird angle of a truck and like maybe has an accident, the regulators might be like, hey, why did this model fail? And if you haven't tracked every piece of your data, you won't know. Was it like you don't have enough examples of that kind of use case in your data set? Or did you have them, but your model didn't pick it up? Or like maybe, something has happened in production, and with monitors and tracing, all of that data is logged. And this is what the AI world needs. You need the health of the model tied to the model behavior and tied to the business metrics, not just a server status.
Yeah. So, I love the analogy of the car that you gave. Everyone can understand it so easily. So, what you're basically describing, Lavanya, is that tying health to model behavior is very, critical for the governance of even agentic AI systems that have completely exploded right now. And how do you trace a failure? When an LLM agent executes a multi-step chain using external tools, you don't just need a status code, you need a full auditable trace of the reasoning, the tools used, and they're all tools from different systems and the intermediate outputs. And I have interacted with a lot of organizations, and they are kind of realizing that the reality is that for a company that is deploying a customer facing Gen AI application, for example, the AI ops trap means that a single model hallucination, if untraceable, can cost you not just hours of debugging, but millions in brand trust. And the complexity directly translates into an unacceptable level of operational and compliance risk. So, what are you seeing, Lavanya?
So I think you're totally right. We see what we end up with is like this really sophisticated observability tool on top of this really messy, ever-changing, infrastructure graph. And the hard part is without tools like the ones that we're building, there's with CoreWeave and with weights and biases together, there's no single place where you can go and say, hey, show me all the requests where, this GPU pool was overloaded and this model version changed in the last 24 hours and the business KPI that we care about dropped. There's no, like, without this combination of CoreWeave who has all the GPU metrics, and weights and biases, who has all your model metrics. No one else in the market can do this. And like what happens without a tool like this is your most senior people are spending all of their time rewiring all these pipelines whenever like a model changes, which right now happens every week because everyone is coming up with a new model, or like a GPU changes, a new GPU drops, or like then you have to spend manually correlating all these different aspects of your pipeline. And the real cost here isn't just the GPU hours, because like that's a big component, but that's just one component. It's the cognitive load and the time spent by your best engineers. And like we're paying these engineers an ungodly amount of money, as they should be paid, but like to take your best engineers and have them spend time on manually correlating things across the pipeline, that is just insane, right? And that is the AI ops trap that we see in practice.
Yeah, yeah. So well said, everyone wants to do creative work. Nobody wants to do the mundane, repetitive, boring work, spending hours. That doesn't get the best of us, right? So this is fantastic. Okay. So now let's get back to the whole discussion, the solution here. So AI native cloud is being touted to be as the escape velocity, and that's the core thesis that we have been tracking. We must stop trying to bolt AI onto infrastructure designed for yesterday's problems, right? We are witnessing the rise of the AI native architectural paradigm. So, the promise, if I'm understanding it correctly from your conversation, is that the promise of CoreWeave and weights and biases isn't just about better integration, it's the fundamental de risking of the operational lifecycle for AI workloads.
Totally. And like you don't de-risk this with just adding one more tool. You need to fundamentally tie together the entire architecture. So what we're building at CoreWeave is an AI native cloud, and it does a couple things differently. It doesn't just take some GPUs and glom on an existing cloud with like pieces that were not made for AI. It only we only build components that are needed for an AI native workflow. So you get pre-configured GPU environments and Kubernetes components, and they're tuned for AI workloads. And when you have this, you don't have to, hand assemble like drivers or your frameworks yourself or play with CUDA. And then on top of that, you get all the tracking of weights and biases. You get our experiment tracking that 1 million, more than 1 million machine learning engineers use. You get evals, you get deployment configs, you get artifacts. And these are all tied together, and they're all first class parts of a singular platform. And this vertical integration is what strips out any accidental complexity that you might find.
Yeah. So, if I may ask you, Lavanya, how does that architectural simplicity immediately solve the trap for the developer? Because here we are heavily focused on the developer experience as well.
Totally. And so for developers, I think it shows up as less friction, and you can run more experiments and get faster feedback, which the cost of, if you can reduce the cost to how fast people can run experiments, that's where the money is. So in an AI native stack, you're not spending days just writing your Terraform, writing YAML files, to guess like what is the right GPU that you should wire in. You're not trying to wire logs from like multiple different systems. You have it all in one place. So the result is you can run more experiments every week. You can debug faster when something breaks. All of the things you need to debug are available in one system. And like, you don't have to glue code together. And like, machine learning engineers, and I can speak as one of them, are not like software engineers. We're not the best at writing production code, right? So if you give us all of our data in one place, we're so happy. So we get to focus on the model behavior and like not on gluing things together.
Yeah. I mean, I can understand, all the developers and the VP of enterprise architecture, they're listening to this, podcast. They're going to love this because, I remember I had done a keynote on this autonomous operations in 2017. It has been an ultimate goal for all of us. And it has been a buzzword for a long time. But what I hear you saying is that vertical integration finally provides the model aware context layer needed for true automation, where the system autonomously manages against business metrics and not just server health. This is not about server and systems and infra being up. It's all about how the model behavior is translating into business metrics.
Totally. And autonomous should not, it just means that our engineers are getting fewer pages. It should mean that it truly understands this workflow that you're trying to do end to end. So with weights and biases and CoreWeave, you can take your cluster health and you can correlate it to GPU utilization, the model metrics, and even the business metrics that your boss cares about. So that is what autonomous operation looks like in an AI native world.
Yeah, I think this is getting a lot of the development side closer to the business side as well, right? So the AI native cloud doesn't just reduce the compute bill. It's not about just eliminating the most expensive drain, but it's about, taking care of all the cognitive load and operational bandwidth of an enterprise most valuable talent.
Totally. And like the metric that matters isn't now just like the amount you're spending per GPU. It's like the cost of every successful experiment. And when we simplify the architecture, we can shorten the path from idea to experiment to going into production. And how valuable is that? You can reduce the number of teams and like the number of tools that you need that have to be in that loop, worrying about every step of that loop. And like that is what I mean by cost control by design. You're not just squeezing the cloud bill, you're reducing the operational drag on your best people. And they're going to be so thankful for that.
Awesome. So, as you said, Lavanya, cost control by design is key to escaping the black hole. And so, before we start wrapping up here, what are the three concrete steps a CTO or a head of AI can take right now?
Yeah. So if I could leave people with three things, I would say measure the time tax, not just the cloud bill. And then I would say run a lighthouse workload on an AI native stack and see how that goes for you. And then the third one, and maybe the most important one, is make model aware observability non-negotiable. Because like if you're working in any regulated industry or even any industry where you're spending a lot of money, you need to make sure you're saving every aspect of your model or you're just losing money. We used to say at Weights and Biases before, those who don't save their experiments are doomed to repeat them. And that is very true. So these three moves are a concrete way out of this black hole.
Perfect. And I have to say, my favorite is definitely that make model aware observability non negotiable, right? Because, we don't want to run into this trap that if something goes wrong, then you don't know and you're not able to debug it in a timely fashion, right? So, okay. So, we have completely agreed here that the AI ops black hole is real. And it begs to ask all of us and the listeners, are you really going to pay for integration debt and cognitive load, or are you going to pay for innovation? The answer in my mind is definitely clear. Architecture is the ultimate measure of success with AI. So, Lavanya, how would you kind of, sum it up?
Escaping this complexity trap is really about treating AI as a first class system, not a bolt on lipstick on the pig kind of feature, you know? Uh, so that means you want to start by choosing an architecture that's purpose built for AI. You want to hold yourself to model SLOs, not just server uptime. You want to tie your model accuracy metrics back to your customer metrics. And you want to design your stack so that your best, most prized engineers are spending their energy on the models, the data, the product pieces, not on the infrastructure glue. And when you do that, the same team that's right now firefighting can spend their time shipping new AI capabilities every week.
Absolutely. That would be such a sense of accomplishment for all the engineers that they are actually driving innovation and moving the needle for their business, right? So that's the key to truly unleashing the power of AI in an organization. Thank you so much for joining us, Lavanya.
Thank you so much for having me, and thank you for asking some really smart questions. It was fun.
I had a blast here. Thank you, everyone, for joining us today. Join us next time as we explore the AI risk blind spot, our general purpose clouds leaving your enterprise exposed. In the meantime, please visit CoreWeave's website for nuggets of insights and guidance on an AI native cloud operational efficiencies. Have a wonderful rest of the day, folks. Feel free to connect with us on LinkedIn and Twitter. Bye for now.